In this video, we are going to be talking about exponents. And so just a quick summary of what we got going on here is that exponents is just a shortcut for repeated multiplication. So if you have the same thing being multiplied over and over and over again, you can shortcut it, represent it with whatever's being repeated over and over and over again, raised to a power. That power represents how many are multiplied together. A couple quick things to keep in mind is anything raised to the 0 power is going to be a 1. Does not matter what it is. And then if you have negative exponents, that anything that has a negative exponent just moves. So if it's just a regular value, it's going to still be that same value, but now it's going to be in the denominator, and the negative exponent turns into a positive exponent. If you have a negative exponent in the denominator and you want it to be a positive exponent, you move it up. Essentially, it moves the whole thing up. So if the power is a -2, it's still being squared. It's just not going to be in the numerator. Okay, so negative exponents just move things. They move things up or down. All right, so we're going to be just focusing on multiplying powers with like bases, and we're going to create some properties here. So here's kind of our look, and then we're going to talk about what we get with this. So if you have x to some power times another x to a power, what do you get out of that? So we'll take this one kind of for example, that y to the third means y times y times y. And then y to the fourth means y times y times y times y. All right, and so all you're doing is just kind of saying how many y's you have all together. I kind of stated as here, you got 3 y's here, you got 4 y's here. So altogether, you're going to have 7. All right, so the shortcut of this is, how else do you get to this y to the 7th? And that is just by adding the powers together. So your property is all about how many x's you have, and you would just add your exponents together. All right, so that's kind of the idea that you're looking at in all these. So this thing, if you don't have a power written on it, then if it helps, put a power in there. So you got 1a here, 2a's here. That's going to make 3a's all together. All right, and that's as straightforward as just adding those together. Here you have a b times a b, so you got 1b multiplied by another b. That's going to leave you with b squared. All right. Again, if you need to add some exponents to it, by all means. And then over here, you got 2 x's here, you got 3 x's here, and 1 more x here. So altogether, that makes 6. All right, so you're looking at x to the 6th. Here you have x's times y's. Well, those are not like bases, so really there's actually nothing you can do to them. So we'll just drop the parentheses, and that's about it. They're not the like terms, so they're not the same bases. You can't put them together. All right, if you throw numbers into the mix, that's okay. Still really the same. You still got 3 x's here and 4 x's here, so that's making x to the 7th. But don't forget, you still have multiplication going on. So when you're looking at the actual numbers, it's just 5 times 2. So that's going to get you a 10. Okay, so you're multiplying the numbers, but you're adding the exponents. Okay, that's why I keep saying you have 3 x's here, you got 4 x's here, so that makes 7 x's all together, and you're still multiplying 5 times 2. Okay, so that was multiplying powers with like bases.